We have Mrs. Rana Özbal and Mr. Fokke Gerritsen. Thank you so much for being with us today. How are you?
Good, thank you. It's a pleasure.
Thank you for inviting us.
We have Mrs. Rana Özbal and
it's a
Mr.
pleasure to
Fokke
be here with
Gerritsen.
you.
Thank you so much
Thank
for
you.
being with us today. So, how are you? I would love to start with the questions. Is that all right?
Absolutely.
Of course.
Okay, great.
Yeah.
So our first question will be, has the introduction of AI and machine learning changed how data is interpreted in archaeology? And how, if it has?
I can say something about this, actually. Should I go ahead, Fokke?
Go ahead. Yes.
So there has already been some machine learning in archaeology applied. There's an article from 2012 where they took satellite imagery and they taught through code writing the machine how to actually recognize sites, and it was quite successful. It identified sites that humans could not identify, and this was already more than a decade ago. So it's something that has been going on. But this whole new change with AI might bring about many other new transformations with things like, and I've been trying to think about like how, but for example, when we try to do some analyses after we run samples with our different instruments, there are sort of libraries that help you interpret, but they're never good for archaeology. They're usually good for modern samples, and perhaps some of these interpretations can be bettered through archaeology. I can give examples maybe later, but perhaps Fokke would like to say something. I don't know.
I think at least like in my archaeological work, I think the same is for Rana. AI machine learning has not had like such a big impact yet, but I suspect that it won't be very long before it will. But these would be applications of machine learning and AI that we are not going to be developing ourselves. And other people will, and then we will see the benefit and be able to apply it. From attempts that I have sort of witnessed other people make to use machine learning, is that even though sometimes archaeology deals with big data sets because they have tons of finds, tons of artifacts, tons of data points on related to archaeological information, these data sets are not typically as large as AI models would need to be able to really interpret data sets so much better than can be done at the moment. With big data, typically you have millions, billions of data items, and that's what AI uses for their learning models. And archaeological data sets are not quite so big. So maybe machine learning and AI will start learning how to use much smaller data sets. And then I think like for archaeology, there can be a big jump in the relevance. And this could be very soon and very sudden, or it could be take a bit longer.
Okay, thank you.
So I also, when I mentioned the examples, it wasn't things that we're applying. It's just that it has been applied a decade ago, some of these things, but in our own personal research, it has not yet been applied. For example, discovering sites. This is an excellent thing that I think we can see more of in the future.
Okay, so do these AIs or machine learnings exist but aren't yet applied as much, or?
Well, some of them, like for example, some coding has taken place in the past to be able to identify sites, and very, very specific. It's a narrow range of
like that,
things
okay.
that it could be applied to. That has been done quite successfully, actually. So this is something that was because there's lovely satellite images of much landscapes from Anatolia, but also the northern Mesopotamia, and you can see the sites when you go from space. Basically, they're from photos taken from space. You can identify these sites and then go to visit them, basically. And we were doing this manually until computer programmers tried to teach the computer to try to figure out how to identify it. And the computers were able to identify ones that we personally couldn't really see. And then when people went to them, sometimes they were, correct. Sometimes there were false positives, but there was already a process that has been applied quite successfully with researchers mainly in Harvard University. So that's something that has happened, and this is bound to, and if it has not already improved since then, and it's not something we follow very closely because we don't do survey right now. We're doing more excavation kind of work. It's definitely going to blossom in the near future with lots of new applications, for sure.
Okay, thank you. Yeah, that's pretty interesting.
Okay, so linking into the question of new technologies helping stuff, has new technologies helped you find new things, find or uncover new things?
It has, but Fokke, would you like to go ahead, or should we?
Find, or if you want to ask, maybe find or interpret the data differently. Finding things, apart from the example Rana gave of like discovering sites that we don't know about yet, because maybe you don't see them when you walk around a area. Not so much in my personal research, but using it to understand or to see like patterns in the data that we have among the finds that we have done in our excavations, for example. Technology has really started to make a big difference, and that's specifically like basically just software packages, computer technology that help us organize our data and go through our data in such a way that it discovers patterns that tell us about how to interpret our finds.
So would you call this something that would be impossible without new technology, or just something that would be sped up?
I think it would be impossible without new technology. But when I talk about this technology, it's technology that's been around for quite a while. It's just basic computers and software programs.
Okay.
Not necessarily the types of applications that you can compare with AI or machine learning that are really developing very fast at the moment.
So one thing for discovery, actually, Fokke, you and I, we both used it, is magnetometry, which is a really old technology where you send magnetic signals into the ground in order to sort of find potential architecture underneath the surface before you actually begin excavations. And we did this already. Actually, it's the site that we are now excavating in Hatay. The previous team already did this in, I guess, the late 90s. So this technology is not new, but it did help, for example, find places where at least some walls could be identified, giving us clues as to, let's go dig there. So technology helping us, identify where on the site to dig. And we, when we began our excavations, the new phase of excavations in 2022, we too went out with a magnetometer, which is a very simple technology, and were able to identify areas that looked promising, and indeed they have so yielded good data and good results. So I guess you can say we've been using technology to help discover things as well as interpret, as Fokke was just saying. But whether this technology is now groundbreaking, it will be. You know, everything is so fast with AI that it hasn't already trickled down into all the archaeological applications yet, I would think. And I think other fields are perhaps developing, and sooner or later we'll see it trickle down into all the kind of software we use, the kinds of interpretation will probably improve. These things are yet to come in many ways.
Okay, so these actually answer one of the questions I was planning to ask.
Oh,
So I would like to ask one of my own, if that's
sure, absolutely.
okay. So we're talking about field work, we're talking about locating areas. How about lab work? How does AI or machine learning, or honestly any sort of
Robotics.
technology affect the quality of the results you get from the lab?
Yeah, that's
I'd
something
love to
that
hear about that.
Yeah, that's a very good question, because we do a lot of the archaeology that ultimately becomes part of the interpretations that we ascribe to sites come from research that's done in labs. There's a lot of recording and then processing, and sometimes actually wet lab kind of research where you digest a sample, or you extract residues or something, and you then put these into different instruments. And typically, a lot of these instruments have various kind of built-in libraries, right? Very basic libraries. So when you put the sample in, it should be able to give you some background, but it has never really worked for archaeology because the sample is very fragmented. Oftentimes, for example, with lipid residues, we have, you know, the molecular structure is broken, so it doesn't really work. What I would expect would happen in the near future is where you have instruments that have the software where it's also programmed for archaeology. So when you get a spectrum coming out, you put your sample in, you get a spectrum, and then I'm expecting these instruments to be able to, whether it's we use infrared technologies, we use mass spectrometers, gas chromatographers, we use lots of different instruments that you might see in the lab for them to help with the interpretation, which has been sometimes challenging. So I expect this is going to come. It has not yet, but it will transform some of the ways in which things are happening. And of course, I think there's dangers there too, right? Because sometimes there's mistakes, and only can a real expert understand and really interpret and read those ones that are problematic and things like that. So I think we have to wait for it to become sufficient, let's say, in trying to help with these things. And we're not there yet. We're not there yet.
So I would like to ask, what kind of physical tools would you actually use in the field work? So these could be anything from digital technological tools to simpler technological tools that could be interesting for STEM.
In the field during the excavations, you mean?
Yes.
Well, in a way, you have been on excavation and first-hand experience of what the tools are that we use, and to a big extent, these are just manual tools, and our excavation project is actually less advanced in that sense than some other projects, because if the basic steps of the process are that we uncover and then document, and then take that document home and the artifacts home with us for further analysis and study, then in our case that involves a lot of paperwork and documenting through note-taking and photography, whereas other excavation projects, and whereas like in theory a lot more is possible with digital tools to record immediately in the field, that we've used and tried to use, but that we don't really have been able to take into our workflow with our teams in the field. But one thing we have attempted, for example, at the basic level, is to create sort of recording programs that you can use on your phone or on a tablet, so that in the field you can immediately, with notes and with photos and with database entries, record everything that you come across in the field, and that saves a lot of time afterwards. But in our particular situation, where we work in the hot sun under very bright light, we've simply discovered that it's really difficult to create circumstances where you can actually work easily with a screen and with data entry on a screen in the field. So we're still looking for the best tools, computer tools, digital tools, physical tools, to be able to make that step, because it would save us a lot of time. One thing where we've actually last summer been lucky to be able to use some digital recording technology in the field was because a team came by with a very high resolution 3D scanner that we could use to record some things in the field. I don't know if you want to mention this, Rana.
Sure. Yeah, I will. But I think also, we do a lot of note taking, that's true, but we do use lots of instrumentation. We use a drone every day, daily, and we take lots of photos from above, making our life easier in terms of actually recording everything. So that's something that's like something that I think most projects now do. And we also use a GNSS system where we can get coordinates directly from satellites, and they're very accurate. I think the accuracy is less than a centimeter. So we can take coordinates and make maps and plans of the things that we excavate using these kind of tools. I don't know if that's not really AI, but it is sort of part of the tool kit that we use daily. And this summer we had a team that came by, and they had this drone which has lots of different features, including thermal cameras and LiDAR, where you can get rid of the shrubs and vegetation and really see the contours of the site, all sorts of different features that were applied. And they also brought with them a so-called structured light scanning 3D scanner, which is a very advanced kind of scanner. And we were able to scan not only actual artifacts that we found, and this is a wonderful way to preserve cultural heritage. You can then record every detail on if it's a vessel or pot, a stamp, seal, whatever, before some of these things we find them, we give them to the museum, and then we can't really compare it with, we find a comparative one a few years down the line, but we've already given it to the museum. And if we can have this light scan of everything, the structured light scan of these objects, then it can really create a database. So these are kinds of things which is very new. The technology is expensive at this time. These are the things that will in time become more normal, more regular as part of excavations. But in addition to the objects, we also were fortunate to find some footprints, actual footprints that were preserved, which is very unusual, because it really gives you sort of a first-hand view on, or first-hand feel to the past. Somebody actually walked there. you can see that. And we use this scanner. It's called a spider scanner. We use that in order to record the finest details. And from that, we can then reconstruct many things. We have experience with this to try to get information on the individual, on the sex of the individual, the height, the kind of gait that went on, the weight, the gait that they may have had, these kind of things can be recorded. And we were able to do the recording in no time. It took just minutes really with this new scanner. So these are kind of things that have helped advance the way in which we record.
Wow.
I have a little quick thing I want to add to this. How would you do the photos before top-down photos before a drone would have been used?
Yeah, top-down photos were really difficult to make. Hey, you want to ideally you want to take photos from above vertically, so that your photo kind of like looks like a plan of what you're excavating. And plans are extremely important to map our architecture, our finds within the architecture, etc. What people were doing in the past was, if they really thought it was important to have these vertical photos, they would try to use cameras hanging down from balloons, from kites, and that worked or didn't work, but you were very dependent on sort of the conditions of the day, whether the kite was flying as you expected it. And sometimes projects would invest in having a little airplane fly over and someone taking some photos as the plane came over. But that's of course not something you could do on a daily basis. So drones have been like a real big, have had a big impact on just sort of like the really necessary daily recording of what you're doing. And at previous excavations that we did, we didn't really have options to have a camera from a kite or a balloon or some other system. But on one occasion, we got the local fire brigade to bring their ladder truck to the site. So from at least like 8 or 9 or 10 meters, but a little bit at an angle, we could photograph it. But that was just a one-time thing in a 10-year project.
And we also did once a cherry picker kind of thing. It goes up the arm, goes up that too. Yeah, it seems so arcane that you would do that once in a decade. And now every day we take photos all the time, in the morning, in the middle of the day, towards the end of the work day, and we can record all these different steps. So these are major improvements in how archaeology has been done. And then what we would have to do, since we couldn't get a photo from above, it would be to actually take a tape measure and measure everything, and with your eraser and your pencil, and you're measuring, and someone's giving you measurements, and then make a scale plan on a big piece of paper. It took lots of time, and now we don't need to do that anymore. So this is a huge improvement that has been, recently. I mean, not recent. I guess it's been. How long? Maybe it's been really a decade or something that we've sort of had these in most excavations.
So what I understand is that digital tools are more used towards recording or scanning. And you did just mention that some of these technologies they've been used since the past decade. It's been 10 years, maybe over 10 years. So what sort of innovations do you think would really highlight the importance of these? What sort of new technologies would even have a better addition as in help to the excavations?
You mean in terms of what would be coming up that would really, or what we would really could really use as new technology for sort of a further improvement in our work?
Do you mean like things that are already invented, but we don't really have, or do you want us to sort of imagine potential future, things that might be coming up, like
I
2,
was
3 decades
thinking
from now?
more like the first one, but both works. I would love to
Okay.
hear both, if it's
All right.
possible.
Well, do you want to talk about the stuff that the 4D lab does? Just to maybe explain some of the technology that they are using, Fokke?
You mean with their sensors?
Yeah, all those sensors and things like that. That's like, kind of really nifty stuff.
So this is technologies used and that are kind of like much more at the forefront of technological developments in archaeology than using a drone with a regular camera, but using other sensors, also with drone technology, to again improve the detail in what we can see, but also to use other like invisible forms of information that sensors can detect, that could improve the way we can see and document what's underground or in the ground at our archaeological sites. So Rana already mentioned LiDAR as a laser scanning technology, but one thing that this lab does, this drone team does, that has also come to our site, is to use a sensor with a drone that measures very minute temperature differences. And so what they do is they fly off the ground, and the temperature may be different, but depending on whether the ground has rocks in it because there's a stone wall somewhere, or whether it has very moist or very dry soil. And they do that at different times of the day. So maybe in the early morning when it's cool, they do it at midday when it's hot, and then they can see differences in how different soils, different parts of the site have heated up or cooled down again afterwards. And that can bring out underground features that you don't see just with photography or other sensors. And this is something that we have not been able to try yet at our excavation site, but that hopefully we can try next summer, and where we are very curious about what this would show at our site. They've done it at other sites, and that has been really helpful to identify underground architecture, underground areas that have shown a lot of have been exposed to a lot of burning and fire, and it can generally help us sort of detect and help us interpret different parts of archaeological sites over much larger areas than we'll ever be able to excavate. When you excavate, you're always bound to a relatively small area, and there you record everything in a great detail. But at the same time, when you have, let's say, an urban site from the Roman period, you can maybe excavate a few % of it, but you might still be curious about like the rest of the city that is buried underground. And I think these kind of like scanning technologies will really be able to do much more for us to get sort of like a map of a city without having to excavate the city than we're able to do now.
Thank you.
So, do you think that robotics could actually help in excavations instead of humans, or in fragile or hard to reach places?
That would be amazing. There might be a robot plan to go into a cave or something like that is already in use. But oftentimes archaeological deposits are difficult to excavate. And we wake up really early in the morning, because when the sun is bright and shining right above your head, sometimes you don't see the colors. We basically, the main thing we try to do, especially in a prehistoric excavation, which is what we do in our project in Hatay, is to try to identify differences between two different soil deposits. And they can look very similar, and you need to get trained and have a good eye. And, it's one of these things that it takes time to be able to learn. And potentially, if there's some sort of way of, I'm talking way in the future, a few decades from now, but if you have some sort of robot that can sort of detect differences and know exactly when one layer ends and when another layer begins and things like that, that would be amazing. And if it does exist already, I am not aware of it. So that's something that potentially could be, and especially I think, Altan, you said like places that you couldn't get to, then that makes a lot of sense. Places where it might be dangerous or things like that. This could be a very useful tool to be able to have some sort of robot that is planned to go. And I mean, this is the kind of thing that they use all the time, right? We've been using robots to go explore different, planets, Mars or whatever, or going into under the sea, the submarines and things like that. I mean, it's something that actually already exists, but it's expensive, and you need to have the right programs and the right tools to be able to actually make it work to answer questions that you really find relevant. So,
Do you think?
maybe I can add something to this. This is just fantasizing, because I don't think it's happening. But you know how robots are used for surgeries, and one of the reasons why that's good is because a robot can be much more precise and careful and consistent and do always exactly the same, and be always completely aware of all the other things that may have an impact on how to proceed. And when you're excavating, and especially when you're excavating something that's extremely fragile, for example, where it's really important that you proceed very carefully and that you do it in such a way that you don't damage in any way what you're actually excavating, you could imagine that robots eventually may be much better than people. People, they get hot and tired and sweaty and start making mistakes, and they're tired and they have to sort of crouch low down for a long time. You could imagine that a robot might do these things very much better. But one thing about excavation is every situation is different. There's no standard, like you have standard bones and tissue, etc., in the human body that you're operating. And that's where it might be really difficult to develop robots that you can not only use in one particular situation, but that you could apply in different situations.
I have a small question to add to this.
Yeah.
Do you see them being used in burials or burial sifting after a burial?
Sifting the ground.
Yes.
That's a good idea.
Yeah, that would be good.
And burial
Yeah.
sifting. Sifting for all the little bones.
Yeah.
So
I mean-
sifting is
I don't know what that is.
yeah,
Oh,
exactly.
Sorry.
Yeah,
Sorry.
no, you can explain. It's to go through a sieve, so you can try to find the small
Oh,
things that
okay.
we would miss otherwise. And I
Okay.
think it's a perfect. I hadn't even thought, but that's perfect, because it's the kind of thing that we have to look very carefully. And if it also had some way of identifying through very basic element analysis or something. Oh, these are the bones, this is the calcium and whatever, that kind of stuff, and find, a range of different materials that wasn't dirt and identify it. That would be amazing. Yeah. Because we have to do a lot of that.
So, in your opinion, what are the most important digital skills for the field, for the lab, that future archaeologists could learn? Are there any to start with?
Well, I think, yeah, there's lots to do with, I mean, there's a lot of things to learn in archaeology right now, and whether they'll be as relevant. Maybe, you know, we do a lot of pattern recognition and statistics and these kind of things, and we compare different things, and perhaps these kind of things will then automatically, you put it into a machine, or you know, whatever, the AI will just, you know, be able to do all that kind of stuff. So, but I still think understanding the basis of how these things work is essential for any interpretive framework. I mean, you can't just assume that, you know, a machine is going to do it. So we make sure that this is part of, at least now, the training that students get. And other tools like GIS are very important for being able to look at spatial patterns. These kind of things, I think, are still essential tools at this point. Whether they become obsolete in the future, time will tell. But what new tools we might need, I don't know. What do you think, Fokke? What new? Are you asking what new tools would be useful for us to learn, for us to sort of try to teach our students?
Yeah, new tools that can be used to raise the future generation of archaeologists, or just in general, you know, skills that they might need to have, being able to use a certain machine, being able to identify or operate some sort of different tool.
Mm-hmm. Well, I think interpretation and having the basis is kind of the most important, right? Because technology is going to inevitably change. And a lot of these things are sort of the skill set that you might need to be able to recognize. You know, we are experts now with recognizing ceramics. For example, we pick it up and we know what kind it is, or layers in an archaeological site, or the results that come out of the analyses that we do. These are the ways in which we work, and we're trained to do these things. And whether all these skills will be taken over by computers and things like that, I mean, it's possible. But I would still feel that knowing the basis of how these things work and why something, you know, you pick up a piece of pottery and you know that it's, I don't know, early Bronze Age or something. And of course, it can happen with AI. I don't know, I have one more thing to add, but before I say it, I'll have, maybe Fokke wants to say something, but there's something that's developing with zooarchaeology that I'd like to talk about. But do you want to say something more, Fokke?
Yeah, I think, like, yeah, of course, like, as new instruments and new technologies get implemented in archaeological research in the field or in the lab, etc., students, new generations of archaeologists generally already have many of the skills that you need for that from their school training or from their university programs. It kind of like develops pretty much in tandem. I don't see like something where archaeology is making a big step forward in implementing technologies, but where there's basically no one around who is able to work with these technologies. Mm-hmm. And now the skills that people in schools are developing using robots and digital tools, etc., as far as I can tell, are pretty much compatible with what it needed for the kind of technology that benefits archaeology. There's not a big gap, let's say.
Right. Yeah, absolutely. something that I thought of and I wanted to mention has to do with the analysis of animal bones. We find a lot of animal bones, and the animal bones are oftentimes extremely useful for us for being able to give us information about diet and climate. And, you know, if you find fish bones and things like that, we find out a lot from them, but they're oftentimes not complete. So what we have is a specialist that picks it up and then says, oh yeah, this is a sheep, and this one is a bird, and this one is this, and they have to sort of identify and do all these things. And in the past, the digital technologies that were applied to it took just too long, because the scanners, you know, the ones before, the light scanners, the structured light scanner can just do it much faster. But before, they would turn around like this, and you would then take, you know, whatever the bone and the object, and it would take forever for it to scan. And by that time, a person could have done it in no time. You know, so, and then once you were able to do that, the computer could then think about it and say, oh yes, this is the proximal end of the sheep humerus or something. It would know exactly what bone it was. But if the machine is as fast as a human in the future, that might be an amazing new way of looking and identifying animal bones, and it could really take things, and then the specialist would just be able to you know, run the samples, put them in a line, and then they would all be done digitally, and then they could consolidate the data and try to do the analyses. These things, I think that kind of stuff is probably just around the corner, because you know, and it could be applied to archaeological seeds, which also morphologically you can change and take a look at their shapes and try to see, is it wheat? Is it a lentil? Is it a pea? There'll be carbonized seeds maybe, and these things have to be identified manually now, and maybe machines could do it and even be able to tell if it's a broken fragment of something else. That kind of stuff, I think, is probably going to come within the next decade, I would imagine.
Sounds wonderful.
Okay, so something I'm interested in is like there is the idea of that robots will take over our jobs. And so there are charts of what jobs would be more common to take over. Is archaeology a field where robots could eventually just take over and be ran by robots?
Well, some of the things that Fokke was just saying, and he, you know, how every site is different, and there's so much variability in deposits in terms of excavation. So we would have to teach, you know, one thing, animal bones are kind of like a sheep is a sheep, right? I mean, you can teach it, it's fast, but, or you can teach all the animals. How many animals are there that people could eat, you know? That can be done. But if it's about excavating and actually digging, I think humans would really need to be involved with those aspects, because it's going to be kind of impossible to do some of these things. The careful stratigraphic excavations that we need to do, these are things that I think we'd still need to continue to do. At least that's what I imagine. Don't you, Fokke?
Well, yes, I agree. But even if we get to a stage that excavating, fine processing, analysis is done by robots or by other technologies, then that doesn't make the work of the archaeologist obsolete, because excavation or survey or trying to get information out of artifacts, that's only sort of the step of data collection.
Mm-hmm.
And the thing that we're really after as archaeologists is sort of like understanding and creating more knowledge about the past. And that's a step where it's really like an intellectual exercise and not a technological or a technical step. So that may eventually also be replaced by by
It
work
might.
done by computers, but I don't really see that happening. Not because of the technical hurdles, but because it would kind of like take away the whole point of doing archaeology.
Could you see a future where archaeologists only analyze and the field work would be done by robots?
I could see it like on paper, like as a theoretical option, but I don't expect it to happen.
So, Altan, I don't know about you, but I'm pretty much done with all the questions I noted down. I just have one thing that I would love to hear from you. So I think this is going to be my last question. So what advice would you give to students who want to combine their interest in technology with their love of history and culture? If they want to be an archaeologist, but they have an interest in STEM, what sort of path would you advise them to take?
Oh, I can say something about this. I think if you're interested in the past, archaeology is one of the best fields to implement because we do use technology much more so than history. I mean, history maybe will use lots of technology with reading things in different ways. I don't know, but we need to use the technology, and we combine chemistry and molecular biology, DNA, all sorts of physics, all the magnetometry that I mentioned, anthropology, zooarchaeology or zoology, geology. I mean, any kind of different field is integrated within archaeology, and there's also all the digital things that the robotics, the STEM part of it with the mechanics and trying to create better all these excavation robots or whatever, if they're going to happen. I mean, there's a lot of different aspects that I think interdisciplinarily can benefit from. Archaeology can benefit, and archaeology can become an instrument for all these different fields in the fact that it's very interdisciplinary. So that's more so than many of the other social sciences, I think. Yeah, and we even have math and statistics. I mean, there's anything you think of, we make use of it. It's almost, we're doing detective work, and any kind of small thing that we can gain using a technology that already exists that is then just implemented, we can make it work in archaeology. So that's why there's all these like lines that will cross over, and I think it makes, I think for me, it makes archaeology special. So there's always something to relate to with other disciplines.
Yeah, you can come to archaeology from many different backgrounds and with many different types of expertise. Like I was saying, there are always ways of implementing them and making them useful. So you can approach archaeology totally without any background or interest in STEM. But if you are interested in STEM, you can try to master any kind of technology or try to develop anything. If you bring that somehow to archaeology because you also have an interest in the past, it will always help you further in whatever archaeological explorations you want to participate in or do or contribute.
Thank you.
Thank you. So let's say you could take 3 technologies that are emerging today or have been or in practical use today, and these could be field and analyzing technologies, and compare them to past technologies and what was used in the past or what was seen new in the past.
So take 3 technologies that have improved significantly in the recent past. Is that what you want us to mention?
Like I asked before, what was the early day of drones?
Oh, I see. Yeah, well, that's definitely one of them. And we mentioned how that's helped improve it. I think many of the
It could also
things
be
that
less.
are,
It could also be, instead of 3, it could be any number you can
well,
find.
anyway, I don't know if it'd be 3, but I basically, there's a lot of new amazing things that have happened with DNA and also with protein analyses. We have had to rewrite many things we've rewritten history, we've written prehistory because of these new discoveries that we're finding. So it's maybe more in the lab part that has been sort of transforming our viewpoints, and these things are going to certainly continue to, as we learn more about, any aspect of chemistry, biology, and things like that, we can then implement these things better into archaeology, and then have even more sensitive interpretations. We might be able to just, date something immediately with a little dating gun. Now we have to send it to the lab, and things happen, and it takes a long time. You pay a lot of money. Maybe it's going to be much faster in the future. I don't know. These kind of things might be developed, and smart STEM people will do all the work, and then we would benefit hopefully in the future from all these things that might emerge.
But I think, as archaeologists, we like to think about the longer time periods, and so maybe it's very useful to think about how technology will impact archaeology from now on, but there's also the question of how it has impacted archaeology so far. And I think very simple things like the introduction of photography or personal computers, they have had an enormous impact on what we can do, what we can record, and what we can retort is the basis of what we can analyze and understand. So in that sense, I think photographic technology, computer technology, and I think what Rana was saying also, the lab technologies that make genetic research possible, they already have had an enormous impact.
I don't have much left, but
So I don't have any questions left either, but if there's anything that you would like to add that we didn't ask about, then we would love to hear.
I don't think so. It's been very thorough, and just talking with you, I feel like new things popped in my head that I didn't even conceive of before we started talking. So it's been a very useful exercise, actually, to talk and discuss. And thank you very much for inviting us.
We
And
thank you for
thank you.
giving your time.
of course,
I think one thing I could add, but I've already said it a little bit, but I think archaeology as a field, as a discipline, is a field that's really open to new people coming in with new ideas on how to implement technologies, how to develop new fieldwork ways or analysis ways through new STEM-related tools. So anyone who has a interest in STEM and an interest in archaeology can always can always have a really productive and useful role in archaeology.
yeah, absolutely. Well said.
So it was our pleasure to have us with you tonight. Thank you so much for joining.
Thank you.
I believe it's been a great time talking with you. I learned things that I probably wouldn't have learned unless I was here. And yes, thank you.
Thank you
It was
very
great.
much.
Thank you, Ishik. Thank you.